Our work is based on what's called powder bed fusion. So we have metal powder, which is laid down on a build plate, and then a section of a geometry, a slice through the geometry, is then melted onto the build plate. And then the build plate goes down, you sweep another thin layer of powder across the top, about 50 microns there or thereabouts, and then you melt that layer onto the previous layer, and you repeat that process over and over. And this is how you can then achieve these very high resolution details with thin walls and small feature distances. The synchrotron, as far as research infrastructure, is crucially important, because the level of resolution that we're able to gain or achieve with that means that we can look inside very complex geometries with very fine detail and very small thin walls and feature distances. And we need them to be gas-type structures. We are able to take our end products, put them into the synchrotron, and then really get down to the subparticle size, so we can look at whether the structures are complete and solid. We can see if there are defects in the structure and how many defects there might be, and then we can change our processes for the machine to adapt the processes to make sure that those faults are rectified. When we actually need to look into the fundamental reasons why and what processes we need to change, then the synchrotron is critical.